Guys, welcome back with a new session for ladder logic programming in our series of video courses. So this session we're gonna talk about the logic gates, and I want to start my session by saying logic gates is the core of the logic programming. Logic gates, as some of you know or all of you know, basically there are three logic gates, which is AND, OR, and NOT. And the advanced logic gates, it is just combination of these basic logic gates. So starting with the basic logic gates here, you can see in the screen, you can see the what's called the truth table. The truth table showing the state of the inputs and the output. We assume here for a logic operation contains two inputs and one output. So inputs such as we talk about BLC. So inputs such as switching, push button, or sensors, something like this, and the output would be like any actuator, like a motor, pump, valve, or light to be on or off. So here there is a formula in the bottom here. So in this bottom you can see 2 of power n, when n is the number of inputs, so the number of states equal 2 of power n. So when we have n is the number of inputs, which is 2 here, so the number of states are 4. But for the NOT gate, you can see it is only one input, so the output would be the number of states would be 2 on and off. So here for the AND gate, you can see the AND gate symbol, like you can see here in the symbol is the on the left. You can see the inputs A and B. You can see in the output is the representing of the A dot B or A and B. So from its name, it's AND gate. So to have the output running, you should have both input A and B are on. So if you can see false and false logic state for the inputs will produce output to false, and if true false will give false, and false true gives false, and when A and B are true, so the output is true. And here on the left is something very important. So this is the timing diagram. So we have the input A has all this period of time on, and before and after it's off, and same thing for B and same thing for output. So you can see between the two red line vertical lines, you can see here when A and B on, output is on. Otherwise, if only one of them is on and the other is off, so the output is off, as you can see in the left and also on the right. Same thing here is the OR gate symbol on the right. You can see its inputs A and B on the left of the symbol, and on the right of the symbol you can see A plus B or A or B. Here is the truth table, and here is the ladder logic. You can see the ladder logic. To represent the OR gate, you need to make both input in parallel, but in AND gate you represent them in series, as we will show you in the programming and the practice with our practice part here. So here's the NOT gate. NOT gate is only one input, and the output is the inverse or the opposite logic of the input, and that can be seen here in the timing diagram. If the input is on, output is off, and on the left and right, if the input is off, so the output is high, as you can see. And there is a truth table. True input gives false, true and false gives true for output, and this is how we implement it in the our session. So let's move to our practice. So in our practice here, let's start from the beginning. So what we have done here is we go into the programming section. So you can see Here's the implementation of the OR gates. We have two contact A, contact B, both of them in on parallel. You can see for implementing the OR gate, and this is the output. So I expect from this OR gate, so I can expect here from the truth table of the OR gate. So if at least one of them is true, so the output is true. So if we gonna simulate this thing again, and we turn on this simulator, you can see when A is off and B is off, so the output is off. But if at least we have A or B is on, so the output will be on. And same thing here, if we have the reverse, like A is off, but we have B is on, so the output will be on. Same thing if both of them, it will give the true. If we highlight here, you can see here in the section of the truth table, you can see false false give false, true false, or false true give true, or true true give true. So moving to the other part for the AND gates. So in AND gates, we just have both of them in series, as I told you. So this is the other switch. So this switch is switch A and switch B. So let's simulate this thing together. Oh, now you can see the green and the orange. That means difference between the program running on the simulator and the program I updated here. So I need to re-update the re-download the program again. Once you re-update the program, you will see it's green, meaning both of them same version. So I just want to simulate this thing. As you can see, if both of them A and B true, it give true. So this is the condition. The only condition to have the output on is to have A and B on. So if one of them off or both of them are off, you can see the output is off. Let's move to the last one in our basic here. Last one is the negative logic of NOT. So output or the motor will be the negative logic of the switch A. So I expect, according to the logic, so A is a reverse of the output. So if we simulate this thing, you can see when the output here is 0, so the output is high. But if the output is 1 high, meaning the output will be the reverse, which is low. Thank you for watching, and hope to see you soon in another session of our video series tutorial for data logic programming. Thank you very much, and see you soon. Thank you.